Last week I missed Rotary. I was in LA working for a couple of days, and I rolled up to the gas pump, and it's the first time I've ever paid over $6 for a gallon of gas for my car. And the reason I paid $6.19 a gallon is because I bought a $13 car wash. Otherwise, it would have been $6.47. I'm not the only one who has had energy on my mind, right? And what an amazing opportunity we have to hear from Sid Green today. Sid is searched after, before I read his formal bio, Sid is searched after internationally for his insights and wisdom in the world of energy. And so this is going to be a fascinating topic today. And thank you, Sid, for joining us today. Sidney Green is founder president of Enhanced Production, Inc., and is research professor at the University of Utah. He is a founder and past president, CEO of TerraTech, a well-known engineering firm that was the first commercial tenant in the University of Utah Research Park. Imagine what that looked like, because I don't know, it's full, but boy, it's nothing but buildings up there now, right? Where he continued as a senior member until TerraTech was acquired by Schlumberger in 2006, where he continued as a senior member until retiring in 2015. And I also found out Sid is a little older than you might imagine. He's aged very, very well. He has published many papers, holds a number of patents, and has given many invited presentations. He has served as director for a number of companies, served on government committees and university advisory boards, and has testified at various congressional hearings. He has served on a number of National Research Council, National Academies committees.
Thank you for the kind words. I'm almost 86. The energy transition has a lot of pieces to it, a lot of players, and in fact, each one of these 13 topics here could in itself justify a presentation on that subject, but I want to cover these 5 things today briefly, and then allow time for discussions and questions, and we can come back to the other one. So let me begin, first of all, by the energy transition news, what's going on. Here's some of the highlights. You all probably know a lot of these, or all of them. Natural gas use is expanding, somewhat replacing coal, particularly in the US, but all over the world. Solar and wind electricity are becoming significant. About 11% of US electricity last year came from wind, and about 3.5% of US electricity came from solar last year. Electric vehicles are becoming prominent now worldwide, globally. About somewhere between 8.5% of all cars and light trucks are going to be electric this year, with China by far leading the way. Geothermal energy, hydrogen, carbon capture and sequestration of the carbon dioxide are being researched and developed. In fact, the University of Utah has probably the leading program in the whole world on geothermal energy right now. It's past $200 million, I think, in funding for their research program. Of course, hydrogen is a big thing in central Utah now. You just saw Chevron acquired controlling interest in the group there. It was announced last week. And the University of Utah also has a significant program on the carbon capture and sequestration. Biofuels are being expanded. About 4% of US diesel is now from biofuel, or now what's called biofuel. The largest biofuel in general by far, of course, is converting corn to alcohol for transport fuel. And most recently, the administration has announced they're adding soybeans to the subsidy list also for biofuels. Nuclear small modular reactors and microreactors even are being developed, and right now in the US, about 20% of our electricity comes from nuclear. The US has about 53, I think it is, operating nuclear plants in the US, and the small scale reactors are affecting us. The Kimmer, Wyoming reactor being developed by TerraPower will be providing some electricity for Utah, and the NuScale reactor going on the Idaho reservation also would provide some electricity for Utah. So we have 2 small nuclear reactors that do affect us, if you will. U.S. has lowered its carbon dioxide emissions. You know, you remember the big to-do about the Kyoto numbers years ago that the U.S. never agreed to? Well, we're actually below those numbers today. We're below the Kyoto numbers on carbon dioxide emissions. And finally, the U.S. continues to spend heavily, I mean really, really heavily, on the energy transition. Let me go next now to some of the actual and potential missteps that the U.S. has made. Some actual missteps we made and potential for the future. So I gave you the news. Now let me talk about the missteps that hindsight is showing we made. Certainly, first of all, has to do with hydrofracking, or with fracking, if you will. 2 decades ago, it was about ban fracking, but fracking has indeed brought unto the world and showed the world the abundance of natural gas, which is the one thing, the big thing, that is helping lower carbon dioxide emissions today. Missing the requirement for solar and electricity, solar, wind, and electricity storage. I mean, that's not rocket science. You know, what do you do when the sun doesn't shine, the wind doesn't blow? But yet it's even today an unsolved problem. There is no large-scale, long-term storage on the horizon for solar and wind at this stage. We were late to appreciate critical minerals. All the hype about electric vehicles without thinking, where is the critical minerals going to come from to make we have to have cobalt and nickel and lithium and electric steel and graphite. Where are they going to come from for these vehicles? And so even today, now we're beginning to wrestle with this. And so where do these come from if we're going to make it? And then finally, the rush to close nuclear power plants. We were rushing to close them down a decade ago. And now we're spending huge money to let's keep them going for a while yet. I think nearly $500 million, $500 million was approved by the federal government to keep the Diablo Canyon nuclear power plant running in California. Some potential missteps that could happen: unwillingness to accept realistic estimates. I mean, the estimates being made are just outrageous. I mean, particularly EVs. We are not going to replace EVs at the electric vehicles at the rate that's being made. We can't possibly do it. Energy emissions required to meet critical minerals. You know, it's not a free lunch. When you produce critical minerals for electric vehicles, they're going to take a lot of energy and have a lot of emissions for that, and we're still not recognizing or accepting that. We often treat hydrogen as an energy. We call it hydrogen. Hydrogen's not an energy source. It has to be made. You have to make hydrogen from other fuels, and when you do, you end up with less than you started out with. For example, electricity to hydrogen is about 65% efficient right now. Carbon dioxide capture and storage, that's a tough one. I mean, we're talking a lot now about let's capture the carbon dioxide from burning of fossil fuels and we'll store it. Well, that's fine, except that's not a free lunch either. It takes a lot of energy, a lot of emissions to capture the carbon dioxide, and I'm not aware of anyone looking at that seriously to look at what is the emissions balance. And finally, the biofuels. For decades, data has been out showing that conversion of corn to alcohol as a transport fuel is at best break even and maybe actually creates more. And now we're adding soybeans to it. And you can guess which state is the most supportive of soybeans. Iowa is a big soybean state. Let me go on to the next topic, is misinformation. There is so much misinformation. Some of it has to be intentional. It can't just be mistakes. One is the talk about phasing out oil, gas, and coal. Globally, about 80% of today's energy, global energy, comes from oil, gas, and coal. 80%. And you're probably aware of this, but you know, right now, crude oil is at its peak, the highest it's ever been, about 103 million barrels a day as we speak today, being used worldwide. About 400 billion standard cubic feet of natural gas, the highest ever on record right now. And the one that it surprised even me, and maybe you all are aware of this, but I wasn't, the world uses about 24 million tons of coal every day, 7 days a week. 24 million tons. Well, the best estimate suggests by 2050, the world probably will be using somewhere between 50% and 100% more energy. Elon Musk, this was online just recently in the last few weeks and says he thinks it'll be more like 200 or 300%. But the best estimate says by 2050, the world will be using maybe 50 to 100% more energy than today. And that will still be probably 70% at best from oil, gas, and coal. Now, there may be some adjustment in the fuel mix with more gas replacing coal somewhat. There's misinformation about what's a primary energy source like oil, gas, and coal, and solar and wind. Those are all energy sources. Whereas hydrogen is not an energy source. As I mentioned, you have to make it. You have to make biofuels. They don't grow on trees either. Well, they do grow on trees actually, but you have to have a lot of energy to convert them to fuel. And so there's real misinformation about what's a primary energy source versus what's an energy carrier or an energy storage device. Another misinformation is often, I even see this in the same article sometimes, the mixing between electricity and energy consumption. Globally, electricity is only about 20% of the total energy consumption. It's a small part of energy consumption. In the US, it's about twice that. In the US, electricity in the United States and Europe is about 40% of the total energy consumption. And finally, we often hear about installed capacities, which are big for solar and wind, and that's good. And it's not really a trick, but it's misinformation not to explain it. You probably, some of you at least are aware of this, but solar is rated as capacity. It's the capacity that the solar panels will produce, the electricity solar panels will produce at the summer solstice, June 21st, at noon, on a clear day when the panels are clean and new. And that's not a trick, but that's just a fact. You have to have somewhere radium, so they do. Well, when you look at solar, at how much electricity you could get on a continuous basis, or the equivalent energy, say, over a 5-year period, load factors are about 20% or so, or even lower in many cases. And so therefore, if you look at the Gadsby plant right here in Salt Lake City, 3 smokestacks, it's a great plant. It's about 1 gigawatt. 1 gigawatt of electricity it produces almost full time, as I understand. And that plant would produce as much as electricity over a 5-year period as 25,000 acres of solar panels. Now, would you rather have 1 Gadsby plant or 25,000 acres of panels? So it's complicated. And finally, on the other installed capacity now of wind is about the same, a little bit higher load factor, maybe the low 20%. Let me go to the next thing about the next thing is unrealistic expectations. The world has gone to these unrealistic expectations. And I don't know exactly why, except the media feeds it. People seem to like to hear big things. The politicians feed this. And the low cost of money when we had low interest rates, almost free money, was feeding it too. But some of the unrealistic expectations are ignoring the scale of fossil fuels, which I just mentioned, and not realizing the scale of energy now for the world. A second unrealistic expectation is underestimating the footprint for solar and wind electricity. And we're already seeing now groups arguing, don't cover my planet with solar panels and windmills. And we've done the low-hanging fruit, and that's good. That is, we've added solar and wind where we could. Now we're finding our transmission lines for wheeling electricity are getting full. It's harder to add. We're finding it's harder to manage the intermittent nature of solar and wind. And we're finding also the locations which are more suitable to everyone are being filled. And so now it's becoming harder and harder to place both solar and wind. Wind is almost totally now being forced offshore. It's virtually, in my opinion, impossible to put a windmill almost totally now in a populated area. It just isn't going to happen anymore because of the concerns about not in my backyard. Solar, even solar, you would think the Mojave Desert, why not you put thousands of acres there and solar panels? Far from it. I mean, you'd think there's nothing there. Well, there is a lot of things there. When you go to run a pipeline or put a solar farm in, it gets turned down. The third thing I would say, the most unrealistic of all, the most unrealistic, preposterous thing of all, is the prediction that one could rapidly expand a number of energy choices all at once, like rapid expansion of electric vehicles, rapid expansion of solar and wind electricity, rapid expansion of the grid, electric grid, rapid expansion of hydrogen, rapid expansion of geothermal energy, and these are all projected by the government, rapid expansion of carbon dioxide capture, and most recently, a rapid expansion of nuclear energy. We don't have a labor supply that could do these. We don't have a technology base of experts that could do these. We don't have the minerals, the raw materials to do these. And the thought that our government is projecting all of these are going to go forward at one time is absolutely preposterous. Let me just conclude, and then I'll allow time for questions and discussions on any of those 13 topics. Let me conclude by talking about the big questions. Here are the big questions I think that are remaining now is we don't know the costs or the consequences of the energy change underway. All we know is that the costs are humongous, they're going up, and we don't know the final costs. We don't know all the consequences as we proceed with energy change. A second thing, we don't know yet if the US emissions reduction will have an impact on the rest of the world. We are lowering our carbon dioxide emissions. We have lowered them, as I say, we're below the Kyoto numbers, and we'll lower them some more. We're fortunate in the US because our mix of energy consumption between electricity and transport fuel is more amenable to allowing us to lower our emissions, our carbon dioxide emissions, and we will. But I can't imagine myself that China, India, Russia, Africa are going to pay much attention to the US. People are starving to death in Africa, and telling these people, would you mind not burning your coal so that we can lower carbon dioxide emission? The president of Uganda spoke at the United Nations over a year ago. In fact, it was almost 2 years ago, next month. And he said very bluntly to the United Nations, I will not sacrifice the prosperity of my people for the Western countries' environmental goals. The biggest question of all, which has now hit the forefront, in my opinion, is carbon dioxide indeed the big cause of global warming? Certainly, the planet is warming, no question about that. The ice is melting. Warming planet is going to lead to some local weather changes for sure. They won't all be bad though, but it is for sure. But the question is the carbon dioxide the culprit? I hadn't even considered this until the testimony presented in July at the federal government at the EPA hearing by two very prominent individuals, not extremists, not people to exaggerate. One was a professor emeritus from MIT, one is professor emeritus from Princeton. They gave a very, very damning presentation regarding the role of carbon dioxide on warming. I don't know if that's true. We are working the wrong problem. With that, I want to now allow time for, and we have quite a bit of time for questions, and I have plenty I can say yet, and we'll lead if we need to, but any one of these 13 things, if you'd like to ask questions, I'll have discussion. Okay?
I get debates about this all the time. I'm from Northern California, where if you don't own a Prius or an electric car, you're not taking seriously. And now I live in Utah, where you have to drive something like gas. But I don't have an opinion on which one's better, but I'm told that if you buy an electric car, it emits just as much CO2 once they're getting rid of the car as it does using an actual gas-powered car. So they're actually the same bad for the environment. Can you tell me which is better, an electric car or a gas car?
We've had electric car in our family since 2007.
Would you repeat the question?
Oh, yes, okay.
Thank you.
Okay, I'll repeat it, and don't mind if I add a little to it. The question has to do with the emissions from electric vehicles versus the internal combustion engines overall. There's data out there now to show that electric cars are not going to reduce carbon dioxide emissions much, and in fact may well increase it a lot. For example, if you look at China, which is by far the leader in moving to electric cars, they replaced everyone except in the US, but they've now replaced Volkswagen in Europe too with the imported their Chinese cars. In China, they're switching from petroleum as a fuel for their cars and light trucks to coal, because most of their electricity comes from coal. So instead of powering their cars with oil, gasoline and diesel, they're powering it with coal, and coal creates more emissions than does petroleum. So the more cars China makes, electric cars, the more they're going to pollute. That's not rocket science, just a fact. North Dakota is the same way. North Dakota's electricity, most of it comes from coal, so they're the same way. So there's plenty of data out there that our politicians, the public could be looking at. The University of Toronto report came out 2 years ago now, showing that eventually maybe you get a crossover where electric vehicles produce less emissions than do internal combustion engines. Might be at 20,000 miles driving on average in the US. But the recent report came out from the Manhattan Institute, came out just a couple of weeks ago. I saw it. It's a very extensive report on electric vehicles. It's very damning, showing that, hey, you may never reduce emissions with electric cars. Here we're putting all this money in electric cars. It is not a big saver for emissions. Now, on the other hand, I've had an electric car since 2007. It's a hybrid. We like it, but I didn't buy it because I thought it was going to reduce carbon dioxide emissions. Wait, there's one back here. Who was back here first? Someone asked a question.
Should there be a carbon tax in this country? And do you think a border adjustment would impact other countries as far as CO2?
Yeah. The question is about the carbon tax and about a border trading tax, if you will, if I understood correctly, on carbon. I'm not an expert on that and don't know that I can speak. Certainly many argue that carbon tax is the only way to reduce emissions, to reduce the carbon dioxide emissions, but I'm worried that these credits like that get traded just like the credit we're trading now on alcohol fuels. And it does lead to money making for the traders, but it doesn't necessarily reduce the environment. So I think if we did have a carbon tax, somehow allowing someone to buy, and we're allowing now you buy credits, if you will, you buy credits now, Amazon, Microsoft are buying huge credits. That's not reducing carbon dioxide at all, even though they tell the people, okay, we bought these credits. We bought lower emissions credits of solar electricity from someone. Well, it just means other people are using fossil energy. So would a carbon tax work? I don't know, but I think that it's very complicated and it's highly unlikely that anything could ever get through Congress that would not be full of loopholes as far as reducing carbon dioxide. Not a very good answer, but I'm just not an expert on that. Let me go here. You had a hand up here.
So the experts who are saying that carbon dioxide may not be the culprit, did they say what might be the culprit?
There's been always talk about whether or not carbon dioxide was indeed the culprit, driven by, you could call it extremists, and some view them as nuts out there. But when I look back at what happened, starting about 2 decades ago now, or a decade and a half for sure, there was a lot of debate about whether or not the planet was heating. Al Gore went on the road arguing about, is the ice going to melt? Is the planet heating? And we spent a lot of time arguing, debating that. If you remember, President Trump for a while said that he didn't think the planet was heating. Well, the planet is heating. So we spent a lot of time. Then in that process, people picked up that of the huge amount of carbon dioxide that's coming from burning fossil fuels, it's about 38 billion tons a year, metric tons of carbon dioxide a year from burning fossil fuel. And it just seemed kind of automatic that then the scientists and engineers began to use greenhouse gas models, which included carbon dioxide, and said that's our model. Now, your part of your question was, well, what might affect global warming? Well, a lot of things do. The sun, energy comes from the sun. Sun's not only is it intensity, but it's the frequency of the radiation that the sun is sending, because that determines how much radiation penetrates Earth, how much stays here on the Earth, how much is reflecting back. Some of it reflects back off the clouds, back down again. It's a complicated effect based on moisture in the air has a far bigger effect than the greenhouse gases, which is primarily considered to be carbon dioxide and methane and fluoro gases. So when the people talk about it and say, well, what does cause it? Those that are most knowledgeable say, we don't know for sure. But the biggest damning part of carbon dioxide is that when they look back 100,000 years or several 100,000 years and compare it to carbon dioxide versus planet temperatures, Earth temperatures, they don't agree. High carbon dioxide periods did not correlate with high temperatures on the planet at all. That's one of the biggest differences. Okay. No, wait, there's someone clear at the back there, very back table, and then I'll come back in. One of you two. The question is, what might be helping to reduce the change in climate? I do not know. Do not know. I mean, the facts, here are some facts that are there that you know too. One is the planet is warming some. It's not warming like people are saying, it's warming a little bit. Ice is melting, polar ice is melting. The ocean temperatures are warmer. Ocean's rising, rise about that much a year, which is not the big deal. The big deal is ocean surges from a hurricane. Those are facts, and it's also a fact that burning of fossil fuels, coal, oil, and natural gas puts a lot of carbon dioxide in the atmosphere. Those are facts. Now, how they affect the global warming, and then what's a bigger question is how warming planet is going to affect your local weather. I mean, you can watch the TV. Our forecasters here have trouble forecasting the weather here. We're in kind of a bowl in Salt Lake City. They have enough trouble forecasting the hour. Can you imagine now somebody telling me that I'm going to forecast what the rain's going to be in Utah for the next 10 years? That's hard to believe to me. Maybe scientists can tell, maybe not. So the answer to your question is a simple one. I don't know. Let's see, somebody over here again, okay. And then we'll you next, okay. Yeah, the questions about nuclear energy and other opportunities with nuclear energy. I've been an advocate of nuclear energy for quite a while, and then about a year ago, a little over a year ago, I began to realize I really didn't know much about it. And so I looked into it and struck up a relationship at the University of Utah with Glenn Soden, who's really a world expert, and some of the people up at Idaho National Laboratory. Yes, nuclear might be a way of producing hydrogen. Right now, going electricity to hydrogen is not very good efficiency. First of all, you have to get the electricity somewhere. And people say, well, we'll use solar, that's emissions free. First of all, solar is far from emissions free. You have to mine the quartz to make the solar panels. You need critical minerals, no solar panels. You have to manufacture, install, and the list goes on. You have to have electric transmission lines for wheeling the electricity from where you're generating to market and so forth. But one way, and it's not a new idea, would be to go just from heat to hydrogen. If you look at the Chernobyl, Fukushima, those explosions were not nuclear explosions, they were hydrogen explosions. When you have very high temperature, water disassociates into hydrogen and oxygen, and then of course as the temperature comes down, it recombines together in the form of an explosion. Fukushima and Chernobyl were the big explosion. Both of those were from the creation of hydrogen, which then later combined and blew up the plants. It wasn't nuclear. Started out as a steam explosion, then went to hydrogen. So making hydrogen might work from nuclear, And I think also the small scale nuclear, to me, has a lot of possibilities. I don't think the US will ever see again another large scale nuclear plant constructed. The last two reactors were in Georgia. They're just coming online this summer. Both of them came online. Now, I don't think we'll ever see another gigawatt size plant. Too expensive. The costs are too high. But the small scale modular, to me, have a lot of room. But our nuclear situation is so wrapped up in, I guess you just call it bureaucracy and permitting, ultra safe, that I don't even see the small scale modular proceeding in the US, but it is rapidly proceeding in China. China has 24 reactors under construction. And so, and other places too. France, of course, gets most of their electricity, or did, from nuclear. Also, I see that to provide nuclear fuel, you have to reprocess the spent fuel. You have to burn it longer fuel than we do by not going to the plutonium stage. You have much higher spent fuel. Our 50 power plants generate about 2,000 tons a year of spent fuel right now, and that has to be processed. And I don't know how many of you are aware now, but we have been getting our nuclear fuel the last number of years from our good friends, the Russians. We had until just a few weeks ago no enrichment plants in operation. Now we have the one in Illinois is come online. It's coming online as we speak. We have another one now going forward in Ohio. We have about a 2-year, I'm told, year and a half to 2.5 years supply of nuclear fuel on hand. And then we either shut down the reactors for lack of fuel, or we have our own reprocessing. But when you say we've been buying from the Russians for the last over a decade and a half, you have to ask, who's watching the store? Back here, a question.
My neighbor was walking past my house the other day and looked at my electric car. She says, "That's not doing any good." And I said, "Why not?" She goes, "Because where do you think the electricity's coming from? That's not really saying anything." I pointed up to the solar panel. I said, "That's where the electricity's coming." And she says, "Yeah, but if you thought about the energy required to make those panels and related equipment." So is she right? Is all this stuff futile, or should we continue to try to do this?
As I commented on electric vehicles, the question has to do with electric vehicles and the electricity and where the electricity comes from for the electric vehicles. I'm not against EVs. Say I've had one, but they are not reducing. There's plenty of data out there. You can just quote the most recent from the Manhattan Institute, big extensive review of the electric vehicles. They are not going to reduce emissions. They're just not going to happen. And it's nonsense. Now, that doesn't mean we should outlaw them. Far from it. I like mine that I have. We have it. And I think some people have them. They're having the terrible effect, though, of raising the price of automobiles. You probably are aware of this. The average price of cars bought in the U.S. in August, I think must have been earlier, maybe it was July, $46,000. When I was at General Motors, cars were selling for maybe $2,500, $3,500 a long time ago. We never dreamed you could sell a car for $50,000 or $75,000 or $100,000. Wasn't even on our radar screen. It's taking a lot more of the consumer money buying cars, and electric vehicles are part of that. So anyway, back to your question about should we do it? Right now in the US, electric cars are not requiring enough electricity to make any impact on the overall electricity consumption. It's a small amount. What it is doing, though, is it's going to create havoc if you have a rolling brownout and your car's out of juice. And you get a call and say, "Hey, please don't gas up your car. Please don't plug in your car." And so you're sitting there, what do? So anyway, and the thought that why we're spending money on all the long range, see, one way of cutting the cost of the car and using less critical minerals, put in smaller batteries. I mean, I don't need a 300-mile range. I drive back and forth in my office, and 80, 90-mile range is plenty. I could drive up to Park City, back if I want to, and I don't need 300 miles. So, but the problem is the auto manufacturers haven't yet figured out how to make profit off of the lower priced electric cars. So they need to sell 70, 80, $100,000 cars. Let's see, way back here, one more and then Nick.
My question is about, and maybe the answer is there is no answer. Is there any, knowledge out there about how to optimize, environmental harm? And what I mean by that is, you see a big focus on CO2. So let's say I have a technology that can take 100 tons of CO2 but releases 2 kilograms of mercury into the water and requires cobalt to do questionable labor practice. Like, is there any way to balance any of that out? Is there any way to figure out what's causing the harm, what's more harmful?
Yeah, the question has to do with balancing out, or maybe looking at the complete cycle, I would call it, the complete cycle of things, so you know whether or not what you're doing does in fact reduce CO2 emissions, balance it out. I've been advocating for quite a while now what's called the complete cycle analysis look on, because that's not being done. Now the government does some of that. In fact, I could quote you some of the reports that go to our senators and congressmen that are just outrageous. If you just read the fine print, it says right in there, but this is not likely to happen. And so, other analysis, well, the National Renewable Energy Lab outside of Denver and the National Energy Technology Laboratory in Morgantown, they do some analysis, but when you start looking at these numbers, you end up telling the emperor he has no clothes. And that's not the way to keep your job. If your super boss is saying, I want to do these things, you're going to say, wait, let's look at this. The more we make, the more we're going to pollute. That's not the way to keep your job. So the answer is there is data out there. Robert Bryce has been talking for over 10 years on the fact, the scale of the footprint of solar and wind, but the media overpowers them. So yes, there is some data there. No, it's not widely known. No, it's not widely being accepted by our elected officials or even by the public, because the media isn't going to. Yeah, it's a good question. The question is what might change the mind of our elected officials, I think, right, regarding more realistic things. I don't know. They're so wrapped up in becoming elected. Certainly House members are running all the time because they're elected every 2 years. Now we're going into a presidential election. There's no reality. It's just get elected. And so when you go, I've gone to talk to our delegation. They're most used to you coming in and they want to know, what do you want? They just expect you want something, and that's what they want to hear. And when you go, so how do I don't want anything. I want you to understand better. They're not used to that. And so I don't know what you can do to get people to, and the choice for election, who isn't very good at times. Take your pick. Yes.
Bill Gates visited Kemper, Wyoming, 4 months ago. Talked to them about converting the whole community into a nuclear power plant. That is likely to happen.
Yeah, that's the one I mentioned, the Kemper, Wyoming. That's sponsored by TerraPower, which is backed by Bill Gates and Warren Buffett. I think both have money in TerraPower, and they're backing it. There is it likely to happen? No, not quickly. They have a new design using liquid sodium. It's a new design that should be more efficient, which they used, which should get the cost of nuclear electricity down. And so therefore, they had a system, and they actually sold contracts to some of the cities here in Utah, but their prices have just been escalated every 6 months, every year, and maybe I don't have all the details, so it's maybe not quite fair to say that, but the price keep going up. They go back to these people and say, hey, look, we got to renegotiate the price again. It's gone up again. And so can it go up? Right now, it's parked because the EU has no idea when they're going to approve or have the enriched fuel. They require a little higher enriched fuel for their reactor. No idea when it's going to be approved. It's certainly 10 years away, in my opinion, for sure. I'll probably be long gone. Anyway, there's also the one at Idaho, which is NuScale, both private companies, and I really commend them, both private companies trying to find new scale is on the Idaho reservation. It's a standard reactor, more likely to get permitting and go forward, but the cost seems to be higher because they don't have the higher enriched fuel.
You comment on the recent advancement in cold fusion.
There ain't no advancements except hyping. Look, cold fusion has been on the table since I was in college. When I was in college, cold fusion was getting so efficient, you wouldn't even have a meter on your house. Be like your cell phone. You just pay a monthly fee. Let me be honest though, too. From a physics point of view, there was advancement for sure.
It's not cold though. I restate your question. Recent advancement in fusion.
Yeah, infusion, that's what I was addressing. The infusion. But from a physics point of view, it was an advancement, but I don't see anything on the horizon to even show that it is ever going to work. Now, I commend those that are working. The U.S. has been spending $1 billion a year now for 70 years. And for 70 years, it's been right around the corner, but it's such a long way away. And so I don't know. I hope it would come through. That'd be fantastic if it did.
Something a little more like the rest of us. My next door neighbor tore it down. As he's master electrician, he's covered his home, his garage, and has additional solar panels put in his backyard. He produces enough electricity that Rocky Mountain Power has come and told him that he can't put up any more panels that he's producing as a transformer from coal. I went to him when I built my house and said, should I be doing the same thing? By the way, we share the same panel. And he said, absolutely not. Because he's an electrician, he could put the panels up at cost, and he put them in himself. And he said the ROI on panels like this, you'll not see return on your investment. It'll take 10 plus years before you even generate what it's going to cost. Is there truth to what he was telling me or not? It doesn't seem that Rocky Mountain Power really wants people to be producing their own power through solar. In reality, they have caps. What's your insight on that?
Yeah, the question has to do with solar panels and return on investment and Rocky Mountain's position on them. And I can't speak for Rocky Mountain. Their promotional, of course, they promote it as a renewable energy and maybe a cleaner energy. In the U.S. now, we have about 160,000 acres of solar panels installed as we speak, and about 4% are rooftop on homes. So it's quite a bit in the U.S. That's quite a few acres, 44,000 square feet an acre. I have a bunch of panels on mine, and I put them on, not that I thought I was really going to make a good return on the investment, but I thought it was just a good thing to do. And so I put them on mine, and maybe it'll raise the value of the home when I'm gone, which who knows, it won't be too long. We'll see. It's saving me, we have a big home above the zoo. It's saving me about $1,000 to $1,500 a year, it looks like. And I've only gone through a year for them so far. If you produce extra, at least in my case, they do buy it back. And there's a limit though on how much they'll buy back compared to what you generate. That's probably the catch he's in. They buy back at 5 cents a kilowatt, but then when I buy from them, it's, what is it, 38 or something? I forget what it is, but it's 5 cents I get when I sell it back. So can you put more on your house to do it? Well, kind of, but one thing that shocked me is how little electricity I produced in the winter. On these hot days like July, I was generating a lot of electricity, more than I used for sure. Even my air conditioners, let them run. I was generating more electricity than I could use, but boy, in the winter, it just goes so far down. It was shocking to me. So at $1,000 to $1,500 a year, saving my unit was almost $40,000. I had it installed. It's a very good unit. It's very top of the line. It's a very good unit. I will never get a return on that investment, not at when interest rates are what they are now. It never works out, ever. So I didn't do it to save money. I did it just, I wanted to try it as an engineer. Yeah. Do we have time yet? No, is the question about carbon dioxide from animals, including people? We do. We all produce carbon dioxide. Uh, That's a good question. You know, when you come to the mix of where does the carbon dioxide in the atmosphere come from? Right now, carbon dioxide is about 420 on average across the world, 420 parts per million of carbon dioxide in the air. That's on average. And you look at where does that come from? Of course, lots going in the air, lots going out. Goes in the oceans, the biggest absorber. Forests, less the same. It looks like people and animals generate quite a bit, but it may be of the order of 10 to 15% of the global carbon dioxide going into the air. So it's not a huge amount, but in California, they're restricting. They passed a law and said cattle could not emit more than so much. Well, I don't know how you keep them from it. You'd have to use special feeds to prevent less gas release, I guess. But the other things that are even bigger is volcanoes. Volcanoes and forest fires put huge amounts of carbon, far more than any electric vehicle is ever going to take out under the best scenarios. But forest fires and volcanoes put a lot of carbon dioxide in the air. And so you have burning fossil fuels is big, for sure. You have forest fires, volcanoes, people and animals, and industry, particularly agricultural products. That also making cement is the biggest polluter. What do you think?
Thank you.
Hey, thank you all.